Alright, so yesterday we have defined about Apache Hive, and we have just gone through some of the basic query setups for Apache Hive, and we have just checked the uh, interactive query setup of Apache Hive with Taze, and the working transformations on Hive on Taze, and basically the working platform execution differences of Hive on MR and Hive on Taze. So today we will go on through a couple of demos on interactive query executions for Hadoop with Apache Hive and on Apache Taze. So in the demo that we will focus basically on taking advantage of improvements of Apache Hive and Apache Taze through the work that is implemented by the community as a part of a Stringer initiative of Hortonworks. So we have just already discussed regarding Apache Hive and Apache Taze as well. So just a quick discussions on Apache Taze. Taze is basically which means a speed which provides a general purpose highly customizable framework that creates simplifies the data processing task across both small scale, that's for low latency, and large scale, that's high throughput workloads in Hadoop. It generalizes the MapReduce paradigm to a more powerful framework by providing the ability to execute a complex directed acyclic graph of tasks for a single job, so that projects in the Apache Hadoop ecosystem such as Hive, Pig, and Cascading, they can meet the requirements for human interactive response times and extreme throughput at petabyte scale data. So typically what we are planning to do, what I did, basically I have already created two Hive tables in HDP sandbox. So these two Hive tables, that's typically named as one of the table that named as HVAC, and one of the table that's being named as building. So these are the two tables that's being already created, and right now, what I'm trying to do is basically I will execute the sample Hive queries using MapReduce framework. Also, at the end of the MapReduce executions, I will execute the same query using the Taze. So we can enable Taze on Hive executions, and we can take the advantage of the directed acyclic graph execution, representing the query instead of multiple stages of MapReduce program, which involved a lot of synchronizations, barriers, and I/O overheads. So that is exactly the improvements in Taze by writing the intermediate data set into the memory instead of hard disks or in HDFS. So let's first look at the improvements um, that's being done in Taze. But before that, we will run the first query on MapReduce. So I'm in the sandbox right now, and you can check the tables that's already present over there on which I'm trying to perform the operation. So this demo would be based on the performance improvement analysis of Hive on Taze. So these are the two tables that's been present already. That's building an HVAC. So for the first demo, I'm setting the Hive execution engine as first as MR, that's MapReduce, and then writing the sample query. Just performing a join between these two tables. So this query would run using MapReduce framework. Okay, so we can note here the time that it takes for the execution of this query. So in this for this query, we have been able to see that the query fetched around 8,000 rows, and the time that it took it's around 114 seconds. That's 114.72 seconds that we can note on this. That's more than 100 seconds. Now we can enable Hive on Tails execution, and we can take the advantages of DAG execution, that's directed acyclic graph, representing this query instead of using the multiple stages of the MapReduce program that could involve a lot of synchronizations, barriers, and I/O overheads. So that's an improvement on in Tails by writing this intermediate dataset into this memory directly instead of storing into HDFS. So to execute Tails as a Hive execution engine, we first need to set the execution engine of Hive as Tails, and then we can write the same query. So you could be able to see the output of the job, which shows typically the usage of the containers. So the execution has been completed, and we'll be able to see that it took that's around 119 seconds for executions over the days. And so we have been able to run the Hive queries on the Taze job successfully. Now let's what we can do. We can rerun the same query again in next step, and we would be doing some of the changes in this query so that it should run much more faster, as it will use a hot containers produced in this step, since we have been using executing the same Hive client session. So let me write the query. So it would run more faster, since it will use the hot containers and on Taze, and we have been executing the job in the same Hive client session. So it has took a significant less amount of time in compared to the previous query execution time. So the job took right now is only 98 seconds, 98.406 seconds, and it fetched 20 rows at a time. A considerable improvement has happened. Now if I want to track the execution as well, what I can do, I can go to the cluster to track the Hive on Tails jobs on HDP sandboxes and the web UI as well. We'll be able to check. So we can check and track the jobs that's been running while the post and the jobs that's been ran over so far. So here are all the job details that could be available. So if you click on history, you'd be able to get more detailed histories for the specific jobs over so far, corresponding log details that would be available for the corresponding app master details. So the next demo that you would be performing, and that's to be based on the query vectorization. So as we discussed yesterday, that what is the vectorization? Basically, when vectorization feature has been utilized, it fetches typically 1,000 rows at a time instead of one for processing, so that it can process up to 3 times more faster with less CPU time. And this could result in improving the cluster utilization, and it is also to address the latency problem in Hive by extensive container usage and reuse. So vectorization feature works on Hive tables with WARC file format only. So let's create first a table, and that could be formatted only as WARC format.
Another one question.
Sure.
Is is that a map reducer will create the sessions like based on the data or database size, based on the query size, or
You mean the MapReduce execution time?
yes, that is almost like if you see the previous query,
Mm-hmm.
like MapReduce jobs are like it is created like 10 or 11, right? Around but that MapReduce jobs is depends on the data, or you pass the query set after data.
Basically, it depends on, first of all, data, that what amount of data you are operationalizing the MapReduce job. Like if it is on some gigs or some terabytes of data, of course it could take less amount of time if you compared to if you're working on petabytes or hexabytes of data at a time. And also since it's MapReduce execution highly depends on the data, and that's why it is much slower compared to the recent speed processing framework days. Also, it depends on the design pattern that is being applied regarding the query execution. So while the developers are developing the MapReduce programs or writing the Hive queries, it's always that's to be taken in mind that what could be the time that the processing time, specifically the time complexity, the space complexity for the corresponding algorithm while building up the query or the programs. So of course the first the milestone that where the MapReduce program times that's to be depends on is the data sizes, and second
Data
comes up,
sizes means
yeah,
it's a table size or entire database size.
it's entire
That
data
means
that
like
you are storing in HDFS on which the MapReduce job is going to work.
okay.
Okay. So I'm creating a table with WARC file format. Okay, so the table has been created. Now we can run the statement to enable the tails. So we can run the following set of query. If execution engine, and now we can run the following query. So we have seen that the time taken to execute this query is around 36.595 seconds. Now let's run the following another SQL query. Okay, so this query took 29.6 seconds. So the earlier query, which took the time around 36.5 seconds, now this query took only 29.6 seconds. So we have seen that how the query, based on the query improvement, the execution time also has got improved. And now what we are going to do, we can run the query that could enable the vectorizations, and then we will rerun the same Hive query from the earlier step. So first enable the vectorization engine, vectorized execution enabled, set the parameter, and now we can run the query. So this time it took only 21 seconds. So we have seen that how much the improvement has been happened with the help of vectorized query plan. The execution time, it's just got compared to the earlier two query execution time. This time it took a typical less time. Because it scales very well, especially with the large data set, the vectorized query plan. Now let's look at the explain plan to confirm that it's been indeed using a vectorized query plan so far. So let's write the following query. So we have seen that in this explain plan, the execution mode was made as vectorized, and when this feature has been switched off, so we'll not be able to see the same line in the plan itself. And in this explain keyword, by using this explain in the vectorization plan, so we are being able to see the different stage dependencies, that stage 1, stage 0 was a root stage, and the corresponding stage plan of executions. Like stage 1, it was working on a TASE framework. The number of ages, the reducers was 2, which was typically less than the first map 1, the simple age, the DAG name, the directed acyclic graph path name, what was the graph names was that. What are the vertices for first map 1 phase? That's map operator trees, table scan, aliases, statistics, select operators worked, expressions, that's expressions typically date, which was a type of string, building ID, which was a type of big int, output column names, which just came up in the query. Statistics that which builds up the numbers of rows, that's 8,000 data sizes has typically worked, but basic data statistics was 1,768,000 basic statistics was there. Group by operators, which works on aggregations, that's a count of building ID keys, that's a date mode that it was worked on hash types of data, and also the output column name, statistics, reduce output operators. If you could check the execution mode in the second phase, it has got vectorized, and then it starts to work with reducer, that's reducer 2. Then we'd be able to see the reduce operator tree, so that's a group by operator has worked. Then aggregations that which are typically worked on the count query, that's the count value which it just took up there. The keys that worked on their mode, that was a partial mode. Output column names that worked for this particular stage, that's column 10 and column 1. Statistics that which defines the numbers of rows that's been covered up so far. That 4,000 numbers of rows has been covered over there, and that works typically on 8,084,000 basic statistics data that's being worked. Select operator that's being worked. Output column names, file output operators, compressed details of the data, statistics, and then that's again number of rows, and table, that's input format, text input format was that, output format was Hive ignore key text, output format was that, and the serializer deserializer, that's Survey for Hive. So it was basically based on the lazy simple Survey type. So all these details that's being available, if we check the explain plan and the execution mode, we will be able to say, of course, it's got to be vectorized during the reduce phase. So if the feature has been switched off, so we'll not be able to see the same line in the plan, but the rest of other that would be same. Next, we can see in the demo the stats and cost-based optimization. That's a CBO. So as we discussed again yesterday, that the cost-based optimization engine that uses statistics within Hive tables to produce the optimal query plans. Now, if we just do a quick recap, that what was the benefits of CBO? So CBO typically helps to reduce the need of a specialist to tune the queries, Hive queries, and also it helps to provide the more efficient query plans, lead to a better cluster utilization. Now, what are the types of stats that's being available? There are typically two types of stats which could be collected so that the optimizer could use it in the decision-making process. So that's one is the table statistics, and another one is the column statistics. So the explain plan feature that could be utilized to see if the correct statistics are being used or not. So the phrases that in which the stats could be collected, suppose while you are inserting the data, so in that cases you could write the statistics as suppose while the data has been inserted, while data is inserted in that mode, you can write as Hive Stats autographer equals to true, that one as false. Similarly, while on existing data you are performing the operations, you are going to collect the table level statistics, so you can write analyze table name partition key compute statistics. So you could write like this. Similarly, Suppose on existing data you want to get the column level analytics, like column level statistics you want to collect. So you can write analyze table name, partition key, compute statistics for columns, column 1, column 2, like this way. Similarly, there are some configurations being available which makes the CBO, that's a cost-based optimization, effective for the queries. Like one of them that could be like, we need to set the following set of parameters, like Hive compute query using stats equals to, can make it true, or optionally can make it false as well. Another parameter which you could set, like Hive Stats fetch column stats equals to true, optional as false. Similarly, we can write like Hive Stats fetch partition, for partition based statistics, stats equals to true, false. Similarly, we could write CBO enable statistics Hive CBO dot enable equals to true, false. So these types of configurations we can make to CBO, to make the CBO has to be more effective. The rest of these four statistics queries we could make for this configuration site, and the phrases on which the statistics could be collected, these are like this, like while the data has been inserted, we could write as Hive stats autographer equals to true or false. Suppose on existing data we want to collect the table level statistics, we can write analyze table name, partition key, and we can mention as compute statistics to collect the statistics details. And similarly on the column level, if you want to collect the statistics on existing data, we can write analyze table name, mentioning the partition as the key, and the compute statistics for columns as the number of column names, like column 1, column 2, like up to n numbers of columns that's been present in the table. Now let's do a demo. Let's run this query. Okay, so we have seen that how much time that it took to execute the query. So it fetched 20 rows, and the time that it took for the execution is more than 150 seconds. That's 158.9 seconds. So just take a note of that, and if we check the execution mode of this query that we executed. So here we'll be able to see that CBO plan, a CBO feature has still not been utilized. So it's not being enabled till now. So this basic statistics is being done in this explain plan. So if I check here in the statistics details, so I'll be able to see that CBO plan is being is not being available. Now what you need to do, we can enable. We will tune into the same query so that it could utilize the cost-based optimization CBO. So let's collect the statistics on the table HVAC. So we can write analyze table HVAC compute statistics. So now we can able to see that the time that it took, that is considerably less amount of time, and we are using already the TASE execution engine. So let's collect the statistics of a few columns in this table. So we have just collected the table level statistics. Now we just want to collect the column level statistics for this table, and also we need to use CBO. That's a cost-based optimization for the column level statistics is needed. Okay, so we have just seen that in the column level statistics, we have utilized cost-based optimization settings, and the time that it took here is um, That's pretty much as around 67 seconds. That's to find out the column level statistics details. Now let's set up 4 settings in the Hive so that we could analyze it far better while explaining the query statistics as well. So let us set up following parameters. Hive.cbo.enable equals to true. Hive.stats fetch column stats as true. Now we can utilize explain of this query that we ran before. So here, after setting up the details, the plan says that it's using the stats now, and in the stats itself, we'd be able to see that the CBO has already been applied. Since we have been applied for this statistics details for the query, we have enabling the cost-based optimizers over there. So it's been using the complete level statistics over so far. So you can see that the basic statistics details also it's being mentioning as complete column stats as a complete. So it's been using the complete statistics over here. So let's rerun the query that we have just executed earlier and observe that how much time it just took this time for execution. So we'll be able to see that there has been a better gain with a good volume of data set when we have been working with a huge data set also. So let's run the query. Okay, so we can just now we can compare the time that it took to execute the data set compared to the the first query that we have executed for the CBO demonstration. I think for the first time that when it ran for the first query that we have executed before enabling the CBO, it took a significant more amount of time. So if we check the execution stage, so it might be took around that's more than 150 seconds. That's 158.9 seconds that it took, and finally when we execute in the sixth stage, that we just re-executed the query now, and we just have observed that it ran that much faster from 158 second to right now it's just executed in 64.329 second. So we can see here that there is a better gain that's being done, that with a good volume of data set than one that we have been working with. Now, in the next demo, what we're able to see that we'll be able to visualize the multi-tenancy competency with Hive Server 2. So there could be the contentions when multiple users run the large queries simultaneously in a cluster. So in that cases, like processing queries with many containers, that could lead to the lower latency. For this, like three controls could be in place, like containers to reuse the timeout principle, taste split web tuning, and also there could be a round-robin queuing setup. So for that purpose, typically to diagnose the Hive Job Viewer that's being available in Ambry. So if you go to Ambry portal and check out the Hive Job Viewer over there. So in the Hive Job Viewer in Ambry, so the purpose of the Job Viewer is as follows: to visualize the execution directed acyclic graph, that's visualize execution DAG, to drill down into any of the individual stages, like for execution status, for duration, and for the number of bytes that has been read and written, number of containers, etc. So the DAG viewer that would be releasing very fast, that could be integrated, might be in the next release of HDP, or it could be releasing very soon. But in order to visualize the job executions visually, so what you could do basically, if we just move ahead into Ambry portal, and we would be able to see that the corresponding job details, execution status for each and every jobs. If we could search by any of the job IDs and by user, by starting time, so you'd be able to go and do for the in-depth analysis for this corresponding Hive job details. So I have just selected a sample job, and here if I say on selecting of this job, I'd be able to see the matrices. First of all, the summary metric for this job, like input, output, the taste task, and the spilled records. I've just selected one of the job that's just a few moments back I have executed, and I'm just gone into the drill down to further analyze the job details, and I've been able to see a very beautiful map details. That's the map phases and the corresponding reduce phase details. That's the map 1 and reducer 2, and the input memory sizes, and this reducer input memory sizes, and the table scan details, the select byte details, that's the corresponding values, the data types, the number of rows that it has worked, the group by operator that it worked, that the names and the values for the group operator. In the reducer phase, that's I'd be able to see that the corresponding the data types, the data values, the basic statistics that's being worked. Also in the similar type, if I check in the reducer, vertices also, I'd be able to see the corresponding key value details, the data types, the column details that could be visualizes over, and the output operators in the file, so that could be able to see. Similarly, in the in the right hand side, what I'll be able to see, that I'll be able to see a columnar, a tabular representation, basically the map and the reducers and the numbers of tasks, the input data bytes, the output data bytes, and the durations for the execution. So these two durations exactly, that being totally, that represents the total job execution time. And in the short, like if I select corresponding job details, so I'd be able to see just one shot information for each and every jobs. Like if I select the reducer 2, so I'd be able to see that the status of that job, the starting time, end time, the task details, the HDFS bytes, that how many reads, writes has been happened, local files written, spilled records details would be visible. Similarly, if I select also the map, so in the map one, that how many phases has been there, the status, the start time, end time, task, HDFS details, like how many reads and how many input data has been read and written, local files details, field records. So that for particular details that could be available here. So let's do one thing. Let's go back to the terminal and execute a simple query, like select count star from track. Now go back to the Ambari portal. Go to Hive. So if I if I want to see that the job execution visually, so I'll be able to click on the various data points, and I'll be able to get the various snapshots on the typical job details. Similar way, um, um, so I would be able to see the various data points as well, and if I just would be selected the corresponding matrices here, like the output data bytes, or the task, number of tasks that has been worked, and the spilled record, so the corresponding details for the specific jobs that could be also being available. And also I'll be able to see directly from the job details, like the Hive query that has been executed, the yarn application, the corresponding yarn application which has been executed, the stages that's being worked, stage 0 and stage 1. Like in stage 0 for this job, the fetch operator has worked. In stage 1, the TASE operator, actually the TASE execution engine has worked. So the corresponding details that could be available, and the yarn status details will be able to see basically the yarn status for the yarn jobs actually that's being worked for that execution of this job, etc. So these are the job viewer that's being available also with the HDP 2.x platform, that's 2.1, 2.2, and very recently they will be going ahead and introduce the a beautiful dashboard as well for this corresponding embedded related job viewer, a more enhanced job viewer that's also going to be available. But currently these are the following diagnosis purpose for the following job viewer is being available in Ambari. That's to visualize the execution DAG, the directed acyclic graphs, and we can drill down into the individual stages for the MapReduce job execution on TASE, on Hive, and by which we could be able to analyze the execution status, the duration of a job, and the number of bytes that's being read and written, the number of containers, etc. So the individual DIG viewer that would be releasing soon, which would be available in Ambari in HTTP. So also there are several SQL query enhancement also has been done in this versions of Hive. So there are some query enhancement support extension that's being available. So that are, number one, that they have been introduced an expanded join semantics, which supports typically supports from table 1, table 2, where table 1 dot column 1 equals to table 2 dot column 2. So expanded joint semantics enhancement has been done. Number 2 enhancement that's being done is the utility of in not in sorry the utility of in not in subqueries in where clause that has got introduced, and it has got introductions of exists and not exist keywords, and it has got enhancement related to correlated subqueries with equality operation only, and also it has got enhancement. It has got basically the introduction of CTE, the first time SQL CTE, that's common table expression. It's being available in Hive. It's being available on HDP 2.1 onwards. And number 6, the introductions of char data type in Hive. Just evolving trailing white spaces. So these are the query enhancement support extension has been happened for this versions of Hive 0.13 and 0.14 in HTTP platform 2.1 and 2.2. There are some authorization system enhancement also has been done, like for SQL authorization, terms of actions in grant and revoke, create, insert, select, drop, delete, all, creating roles and grant with admin option, and also using views to restrict data visibility. So these are the authorization system enhancements has been done with the recent versions of Hive 0.13 and 0.14 in HTTP 2.1 and 2.2 platforms. So these are the updates that has been done and that has been improved till now in HTTP platform, and simultaneously, we could also see that we could also visualize the enhancement that has been done using TASE platform. That's a TASE framework on the Pig as well, like on the framework of Pig as well. So typically we have already gone through some of the basic introductions on Pig and how Hortonworks is involving with Pig. That's recent versions of Pig, that's 0.12. So Pig, as we typically understood, that it's a high-level scripting language that was utilized with Hadoop. Pig excels typically in describing with data analysis and problems as data flows. So we can also gone through some of the very quick examples of running faster Pig Latin scripts on top of TASE framework. So we can just go through the demo as well. So Pig typically It's a good example of Pig application is basically the ETL transaction model that describes that how a process will extract the data from the source, transform it according to the rule set, and then load it into the data store. So as we know, Apache Pig can ingest the data from the files, streams, and other sources using the user-defined functions, that's UDF. So once it has the data, that it can perform the select, iteration, and other transformations over the data. Again, the UDF feature allows the passing the data to a more complex algorithm for the transform. So finally, Pig can store the results into the Hadoop data file system. And Pig scripts are translated into a series of MapReduce jobs or a TASE directed acyclic graph that are run on the Apache Hadoop cluster. So as a part of the translation, the Pig interpreter does they perform the optimization to speed executions on Hadoop. So what the data processing that could be doing. So we are going to basically, first of all, in this demo, we are going to read a baseball statistics file. We are going to compute the highest runs by each and every player for each year. The file has all the statistics from 1871 to 2011, a pretty much huge data set, and it would contain almost over 90k rows. And once we have the highest run that we can calculate, we could extend the script to translate the player ID field into the first and last names of for the each and individual players. So for this demo, for the faster Pig Latin scripts execution on TASE, I'm go ahead and download a sample dataset. Okay, so the data has been downloaded. Now I can unzip the data. Now what I need to do, I need to upload this data from the local drive, local for directory into HBase. So two CSV files we have moved into HDFS. Now we can run pig first on MapReduce, and then we would run pig with days. So let's first create a pig script. So we have run in this script, in the pig script, some sample relations like batting, where we have just loaded the data into the pig storage from the HDFS stored CSV file, and we have then implemented another relation that's called row runs, where we have just performing the filtering operations on the batting by which is greater than the corresponding run details. That's and in another relation on run, we have just performed an iterations and to generate the maximum runs based on the player IDs as years and as a runs. Then we have made a relation called group data that would be just performing the group by operations over the year. We have performed a relation called maximum runs, that max runs, that could perform the for each loop just for iterations of a group data to generate the group as the to calculate the maximum numbers of runs as the max runs, and in the join max run um, relations, we are performing a joining between the two relations that max runs by a number run values, and the maximum runs, that's max runs relations, and which could be again grouped as runs by years and the total numbers of runs for the data set. And finally, in this final relation, that join data, we have performed that for each loops operations and iterate this maximum runs generated by year, player IDs as the total numbers of runs, and finally we just wanted to describe the output. So once we're done up to this, you can save and exit the script. And now we can execute the pig script by using the default MapReduce engine, simply by typing as pigdemo.pig. So typically it could take a little more time since it's running on default MR engine. So it could take more than 2 minutes to finish on the single node pseudo cluster. So while the pig job on MapReduce that's been running, so in another terminal, I just started the same pig script with days using this following command. That's pig -x in the days mode and the pig file script. That's pigdemo.pig. So as we can able to see that the total time that it took while using the MapReduce engine for processing, that's more than 7 minutes. That's 7 minutes 54 seconds 23 7 minutes 54 minutes that's 23 milliseconds that it has got to be taken. That's more than 7 minutes it could took. Similarly, the same query, the same script, if we could execute through with days. So since in the default the TASE libraries URIs is not defined within the pig class path, so that's why we have been able to see that the following message, that's error. So what we need to do basically, we just need to define the TASE library.lib.uris in the corresponding TASE configuration directory, which contains the TASE site.xml to the environment variable of pig-class path. So the only required entry for TASE site.xml that's need to do is to enter the tase.lib.uris. So the only thing that's need to be done is to identify the tase site.xml and just add the following entries. So to configure the TASE framework on HDP sandboxes for Pig, so what we need to do, we need to install the Stinger technical preview, that Stinger phase. What I can do is basically, since we are in the VM, so we can download the Stinger preview, the Stinger project preview quick start package. So let me configure this quickly. So I've moved that extracted Stinger preview folder into a folder called Stinger preview, and now I can install and configure TASE. So if you are working on sandbox or on the cluster, so TASE would not be included by default for Pig. So you need to add it explicitly. So I've extracted the taste folder and now creating a directory on HDFS for taste. Now I can deploy the taste files to HDFS. Now I can deploy a sample taste configuration from the quick start bundle. So as I can see here, basically that taste URI lib taste.lib.uris, this property is already defined. So if it is not defined, so we need to add it explicitly in the taste.conf directory and to the environment variable of the peak class path. So this is only the required entry that we need to do to run the pig on pig script locally using the Taze execution engine. There is also a Taze local mode that runs a pig script locally on Taze, and Taze local mode is still in the experimental stage. For that purpose, we need to use only as pig-x Taze underscore local, and then we can specify the pig script. And So typically right now there are two limitations are there in Taze mode. First of all, Illustrate is still not yet supported, and the Taze UI is not ready, but you would be able to see that the AIM or container logs that could be available in Node Manager Web UI. So I'd be checking in this particular sandboxes regarding the Pig script executions on Taze, and probably we can check details on this maybe in tomorrow's class. And so we'll be covering up the Pig script executions on Taze, and basically the WARC file format executions with binary data file format, which has been used in Hive, so we can utilize that file format in Pig as well, in Hortonworks Pig 0.14 version. And we could be able to see some of the new features on Hortonworks HDP Pig, that's using predicate pushdown. That's in Versi storage. There has been implemented a new interface called load predicate pushdown. So with the predicate pushdown, we could be able to utilize the statistics that could be stored in the Versi file, strip, or the row group, and that could help to eliminate some of the blocks centrally. So we'll be able to check that demo as well. And also I would be showing the automatic UDF dependent jar files, some of the load function, store function, eval function, which could depend on external jar at runtime. So Pig user then needs to register those jars manually in Pig script, but with Pig version 0.14 onwards, it's possible to declare the runtime dependency inside an UDF, so user don't need to manually need to register each and every time. So we can do this by using some of the Avro storage. So we would be checking that the demo tomorrow. Probably today we are running out of time, so tomorrow we would be checking on that. And also after that we will be focusing on the next module, that's module 4. I think that was the part of Hive part was the part of module 5, and also the main module that's being left until now, it's a module 4, that's on Yarn and MapReduce. And once we have covered the Yarn and MapReduce, we will be checking some of the processing module, that's building data jobs with UCs and HBAS sectors, and finally then we go ahead with our final module, that's HDP security. So that's the plan for tomorrow, and you could let me know if you have any questions regarding today's session. And all the demo steps that I performed for Hive, that's on Taze, the steps regarding the performance improvements of Hive on Taze, performance improvements of vectorized query, cost-based optimization plans, multi-tenancy with Hive Server 2, and SQL compliance improvement. All the details step by step that I'll be providing in the document. So let me know if you have any questions, and then we can wrap up for today.
Thanks, Nandita.
Okay, all right. Thank you guys. Thanks for your time. We'll be meeting tomorrow again. Thank you.